Hello, chemistry students. This is a very brief video that is going to discuss the difference between the formation of ionic bonds and the formation of covalent bonds, which are found in molecular compounds. So what we learned in the last unit is that ionic bonds form when electrons are transferred from the metal to the nonmetal. And the result is that each of those atoms is going to have a full valence shell. And so once our electron moves from the metal, in this case sodium, to the nonmetal, which is chlorine, what we have are two oppositely charged particles. So sodium has transferred its valence electron to the chlorine, and so now it has no dots around it, and it carries a positive charge. Chlorine, however, now has 8 electrons in the valence shell, and because it gained 1 electron, it now has a negative charge. And so now they both have full valence shells, and now that they are oppositely charged, they are going to be held together by the electrostatic force. And that's simply the force that holds two oppositely charged particles together. So our ionic compound, sodium chloride, is going to form because sodium transferred its electron to chlorine. The formation of the bond in molecular compounds, that is the formation of covalent bonds, is going to occur differently. Instead of electrons being transferred from one atom to another, instead two atoms are going to share. And in these cases, the two atoms are non-metals. In the ionic compound, you had a metal and a nonmetal, but here you're going to have two nonmetals. So the sharing of electrons is going to happen here. And so if I have my hydrogen atom that has one valence electron, and I'm going to go ahead and use chlorine again. So chlorine, as you know, has 7 valence electrons. Well, instead of drawing the blue arrow like I did on the other side to show that an electron is transferred from hydrogen to chlorine, instead, I am going to draw a circle here, because what's going to happen is that this electron from chlorine, this one that is separate, the one that is an unshared electron, or an unpaired electron, excuse me, this is going to spend some of its time around the hydrogen atom. That way, hydrogen has 2 electrons in the valence shell and therefore achieves a full valence shell. Because remember that hydrogen only has 1 proton and it only has 1 electron. Remember that this very first ring around the nucleus can hold 2 electrons maximum. So by sharing this green electron with chlorine, then it's going to achieve a full valence shell. On the other hand, chlorine only wants 1 more electron in order to have a full valence shell. Well, instead of actually taking it away from hydrogen, instead what's going to happen is that chlorine is going to share that pink electron with hydrogen. So that pink electron is going to spend some of its time around hydrogen and some of its time around chlorine. But the way that we show this is going to be a little bit different. So now we're going to take our hydrogen, we're going to have our chlorine. Now, since hydrogen only has 1 electron and chlorine has 7, we're going to put chlorine's electrons there, and then the 2 electrons that I circled are now going to be represented by a bond line. And so if we look at this even more closely, I'll use purple here. Here we can see that if we put a box around hydrogen, it has 2 electrons around it, so its valence shell is full and it's happy. And if we draw a line around chlorine, we can see that it has 1, 2, 3, 4, 5, 6, 7, 8, because remember that a bond line is going to represent 2 electrons. And so my chlorine is also happy because it has a full valence shell. So I just wanted to show you the difference between ionic compounds where electrons are transferred from the metal to the nonmetal in order for the two particles to have a full valence shell, and what's actually happening in the formation of molecular compounds, in the formation of covalent bonds. Here you have the sharing of electrons in order to allow for elements to have a full valence shell. All right, everyone, thanks for watching, and I'll see you next time.